Okay, guys, we're in golly. Section 2-2. All right. This is where we solve equations with variables on both sides. This is moving pretty quick here. So I think we might have to do some backfill with like two-step equations and stuff like that. But when I did the copy right here, I don't know, you can't really like interpret this stuff. So I did it for you, right? So Jackson and Brian collected an equal amount of money during a car wash. They collected cash and checks as shown below. If each check is written for the same amount, X, what is the total amount of money collected by both boys? Explain. Okay, so the key here is that they collected an equal amount of money. So what we can do is we can actually take their kind of amounts and set them equal to each other and then solve. What we need to figure out is what it's written for, right? So X is equal to the amount on the checks, on each check, right? Because it's the same. It says that specifically. So there are 14 checks here and $15, and then $50, and then 7 checks, right? That's too small for your account, so I just wrote it up there. So what we're going to do is, let's see here. We're going to set up our equation. We've got $15, and we have 14 checks times the amount on each check, right? So 15 plus 14x is equal to $50 plus 7x, like that. So that's our equation right there. So now we're going to solve it. And since we have like terms in that 14x and that 7x, we can combine them. I can bring this 7x to the other side by subtracting it over here, just like so. And so we're at 15 plus 7x equals 50. And then we subtract 15 over here. It's positive, so we do the opposite, right? So we're left with 7x equals 35. Excuse me. Divide by 7, and we end up with x equals $5. So, man, those people wrote a check for $5 with cheapskates. That's ridiculous. Terrible. Yeah, I don't know. That's it right there. It's a fairly simple equation. This is an equation with variables on both sides. You have an x on the left and an x on the right. That's what we're going to be talking about today. And the idea here is you bring it to the other side. You bring one of them to the left side. I like to go to the left rather than to the right. Then you combine your like terms, and then you bring that over. You combine that like term. Okay. This is a fractional one. Fraction suck, but we'll fraction bust it. Okay. Joan and Lizzie are making smoothies with the same amount or the same number of fluid ounces. That's the key right there, right? How many ounces of yogurt X are in each container? So you have 6 ounces of juice with 4 containers of yogurt, and we're figuring out how much X's number of ounces in the yogurt container. In yogurt. Okay, so 6 plus 4x for Jonah, right? Because it's containers of yogurt times how many ounces is in it. And since it's the same amount in each smoothie, we can set it equal to 12 plus 2.5x. But actually, let's take this 2.5. And before we even put it into the equation, let's convert it to an improper fraction. 2 times 2 is 4, plus 1 is 5, so that becomes 5 halves. So that's 12 plus 5 halves x. Now we could solve this kind of the old-fashioned way where we subtract that 5x over here, and then we have 4 minus 5.5x, and then you got to like convert and get your decimals, your denominators in there. But I'm going to fraction bust it. So we need to figure out what number we're going to multiply by. In this case, it is 2, so it's very easy. So we can just multiply everything by 2. 2 times this, 2 times this, 2 times this, 2 times this. 2 times 6 is 12. 2 times 4 is 8. 2 times 12 is 24. And then 2 times 5 is 10. Divided by 2 is 5. So those cancel, and we go back up to 5 right there. Okay? So now we want to bring this over here, right? An easy way to figure out which way, whether you bring that to the left or that to the right, is figure out which number is not going to give you a negative. So, right? And so if we subtract this 5 here, 8 minus 5 gets a positive 3. That's a good indication that we've done the right thing. Okay? All right. Let me subtract 12. And we're left with 3x equals 12. We divide by 3. And we get x is 4 ounces of yogurt in each container. Ta-da. Okay. So we're going to convert this to an improper fraction. 2 times 3 is 6, plus 1 is 7, so 7 halves. W plus 8. 4 times 3 is 12, plus 1 is 13 fourths, W plus 10. And now we're going to fraction bust it. You could say 2 times 4 is 8 and then multiply everything by 8. It's a very easy way to figure out what number to multiply by when you're fraction busting. Or we'll just multiply by 4, because 4 divided by 4 is 1. And 4 divided by 2 is 2. So that gives you whole numbers, right? So yeah, 8 would still work, and it's probably easier to figure out that number if you have trouble figuring out what number to multiply by. Oh, and they're equal to each other, my bad. So we're multiplying 4 times everything to get rid of those fractions, right? So you could think about it as either 4 times 7 is 28 divided by 2, or 4 divided by 2 is 2 times 7 is 14. So 14W plus 32 equals 4 divided by 4 is 1. 13W plus 40, like so. Doesn't that look much easier to deal with than that fraction right there? It's the exact same thing because we multiplied by the same number to each thing, so we're all good. So we subtract that 13W, cancel that out. We're left with W plus 32 equals 40. And then this gets very easy right here. We subtract 32, and we get 2W equals 8. Ta-da! All right. Teresa earns a weekly salary. These are decimal coefficients, right? Rather than fractional coefficients. Sorry, those are fractions. These are decimals. Teresa earns a weekly salary of $925 at a 5% commission. So that's 0.05, and we'll call it X. X is the commission right there. And Ramon earns a weekly salary of $12.50 plus 0.03x. Gosh, I'm running out of room. Sorry about that. Let me write it down here. With what amount of sales? Oh, sorry, x equals number of sales. My bad. Sorry. Yeah, because your commission depends on the number of sales. That's right. Okay, so 925 plus 0.05x equals 1250 plus 0.03x. So we want to combine like terms. Like terms are this and this, so we will subtract that 0.03x here. We get 925 plus 0.02x equals 1250. We subtract 925. And we end up with 0.02x equals, let's get our calculator out. 1250 minus 925 gets us to 325. And we divide by 0.02. 925 divided by 0.02 gives us to 46,250. Yeah, is that right? Let's see. 925. No, 325. My bad. 325. That's it. Divided by 0.02 gets us to 16,250. So that's the amount of sales that basically makes them the same amount for the week. So if they have that 16,250, they'll make the same amount of money, even though they have different commissions. Solve equations with negative components. Julia has $410 in a personal bank account and then withdraws $19 per week. And then Kendrick has $10 and then deposits $31. Okay. So let's see. After how many weeks will they have the same amount in the bank? X is the number of weeks. That's what we're looking for. That's our variable. Okay, so so if I take this 31 over here, this negative is just going to get bigger. So what I'm going to do is, rather than going to that side, I'm going to bring it over that side. I'm going to add 19 over here. So I'm left with 415. Oh, sorry, 410. Why did I say 415? That should be 410, right? 410 equals $10 plus 50x. We subtract 10. We get to 400 equals 50x. We divide by 50, and we get to 8. So in 8 weeks, they will have the same amount of money in their account. Okay, so I'm going to fold this in two, like so. Okay, so this is going to go on page, I think, 20. Is that right? Yeah, page 20, 2-2. Solve equations with variables on both sides. That wasn't too bad. Hopefully I didn't go too fast for you. with variables on both. Oh my gosh, I'm running out of room. Both sides. I'll glue it in a second. 2-2, solve equations with variables on both sides. Page 20. Okay, there you go, guys.